In my first video, we have created this block diagram, and now we'll create the schematic for this Lora module. So here, this Lora schematic symbol I have downloaded from this snap PDA. So it has option here. We can download the library for Kicad. So Kicad option is right here. So we have to log into a snap PDA and we can download the library of this RA01H with the step file. So this is a schematic symbol, footprint, and this is our step file. And similarly, I have created this antenna symbol manually, and the footprint, even the footprint I have created manually for this antenna. And with 3D Content Central, we have to log into this 3D Content Central, and we have to search this spring antenna. This GSM spring antenna step file I have downloaded from here. So we have to format, we have to select this to a step and then AP214 and then download the file. Okay, so I have downloaded the file, and after creating the footprint, by going to footprint properties, I have also added the step file of it. By clicking here, we can browse the location to our local drive where we kept our file after downloading from 3D Content Central, and then we can place it here. After browsing it, it will automatically come to the footprint area. We have to arrange the setting of this rotation and offset. For rotation, I have kept this -90 and -90. And the schematic symbol I have created, and here in this spring antenna, we'll go to symbol properties and we can add the footprint directly by browsing the miscellaneous library. So my antenna is in the miscellaneous library folder, so I have browsed it to miscellaneous library and selected the location of it. Okay, it is done now, and now what left is, this is the data set of this Lora module. I am using the Lora module of this AI Thinker RA01H, and the first schematic is the schematic of component that is inside this AI Thinker module. So this is the internal circuit of the module, but when we will use this module with our controller, we have to use this application circuit. So only we have to just interface it. And here we have this 3.3 volt power supply recommendation. So current should be over 200 milliampere, and it says to use the LDO power supply. If DC-DC we are using, then ripples should be within 30 millivolt. Okay, so we will select power supply of LDO configuration, not DC-DC. Will not use DC-DC, will simply use LDO, and will convert 5 volt into 3.3 volt. And the Lora module always take a small amount of current, so this 2 ampere looks high to me. I'll go to electrical characteristic and check the parameter. This is the maximum voltage of the model, and this is the 0.2 minimum. High input logic is minimum 0.8, then again low, then high 0.9, so it looks okay. And now the current strong anti-interference can minimize current consumption. Current low power consumption, the receive current is 12.15 extended by 1.6, and the maximum output current is 105. Okay, and current should be over 200 milliampere. So if we will select LDO of 1 ampere, then that would be enough. Here in this data sheet, in the recommendation there is 2 ampere given, but we can use LDO of up to 1 ampere. So we will try to use the LDO up to 1 ampere. So I'm selecting by searching into DG key, I'm selecting this part number LM1117. I might get the footprint of it, so I'll directly go to Snap EDA. I'll select it, and then I'll directly download the part for Kicad. Kicad is here, so I'm using version 6, so before and later. Select the downloaded file, then I'll go to my libraries, then Snap EDA, then I'll get okay. So I'll go to a schematic symbol again, I'll go to integrated circuit, and then I will import this symbol, integrated circuit, Snap EDA LM1117. Okay, added. Okay, and now I'll go to symbol properties and I'll change parameter. So manufacturer name, manufacturer part number, supplier part number, reference, this is manufacturer part number, and Texas Instrument, and supplier is DG key, and then supplier part number, then description LM1117. Okay, same again, integrated circuit here, then again import, then electro, Kicad project, Kicad libraries, integrated circuit, Snap EDA, then this is the library, then save, then view, 3D viewer, it is only footprint, so I will add a step file. We'll check a step file is here, so we'll go to footprint properties and then here browse to the footprint, then step file. Okay, snappy step file. Okay, copy it and then I will place it here, and then from here I will just fetch the file and then rotation 90 degree, rotation 0 and 90. Okay, 90 0. So x will be minus 90. Okay, footprint looks okay to me, and then okay, now area 0.5, 0.5, press control. Okay, 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 save it. Okay, now it got saved. You can also check the pads, paste and mask and copper. Alright, okay. Okay, so this is okay, and this is also okay, and last one, this also looks okay. Okay, alright, so copy viewer 3D viewer looks okay to me. Then again we'll go here and then again go to file and then symbol properties and then footprint, integrated circuit, Kicad, and then select it, and we can also add the dataset link. We'll save it. So pin 3 is input, pin 1 is ground, and pin 2 4 is output. Okay, check the dataset. The package we have selected is SOT223. SOT223. So this is the package. So input is, take this snap, come here. Okay, so pin 3 is input. Pin 3 is input, okay, and pin 2 and 4 is output, right? Pin 2 and 4 is output, okay, and then pin 1 is ground. Okay, so pin 1 is ground and pin 1 is ground. So we have checked it and it is okay, and then we'll come again here and then add the file from the library LM1117. Okay, so now we have our schematic symbols. We can complete our rest of the schematic. Alright, so we'll press W and then W, W. So W I'm using to wire this connection. Oh, it got missed here, then W again, and cancel W, W. Okay, so now what I'm going to do is I need capacitors. Here 1 UF, capacitor 10 UF, $22. Okay, so again 10 UF, capacitor, and then 47 UF at the input side, $47 100 UF and 100 UF. Okay, so I'll name it 100 UF. Okay, okay, all right. Now wire the connection. to ground. This is ground. Okay, copy it again, place it, and then add power. So input will be 5 volt and this will be 3.3. Okay, place capacitor, then 100 NF, 1 UF, and then 10 UF. And then 10 NF. Place ground and then 3.3. Okay, cancel, save it. What I need is inductor and 2 capacitors. Passive. Okay, save it and then we'll look for some inductor ferrite bed. So ferrite bed, I'll check the part number here. Or we can simply add 0 ohm resistor. Add resistor 00603 and then add here and 10 NF, 100 NF, NC, if we do not want to include this NC component in our BOM file, then we can take this exclude from bill of material in attribute section. exclude. Okay, this is also excluded and this is also excluded. All right, simply place here w w. Okay, and then antenna. Okay, okay, we do not need this entire DIO. We better select this only 2 DIO, press Q and then mark it, because we do not need this. Okay, and now we can add text here for Lora module, and text size 100 bold. Okay, then press I. Okay, and then double click, mark it rate 2, and then solid, and then 20 mil. Okay, 150. Edit rate to 20 solid. Okay, save it, and then add Lora reset. And then Lora DA1, or we can say Lora interrupt 1 or INT1. Lora GPIO input. Okay, oh, these are bold, it has to be normal. Okay, okay, and then RF 50, antenna 1, Lora clock, and Lora chip select, and Lora Moshi, and Lora Misho. And now we'll add this global label. Press X, copy it, paste, and it is input. Okay, and copy it, copy it and then paste it. This is Lora interrupt output. Copy, paste input. X, copy. This is input. Lora clock, and then this will be chip select. Chip select is also input, and this is master output slave input. So this Lora is a slave, so it should be input. So copy and then paste, and this is slave output, so this will be output. Okay, so paste setting, gateway revision A, and this is Lora gateway revision A, and this will be 2022 02 13. Okay, save it. So we have completed our Lora module schematic, and now we will proceed with our other schematic. See you in my next video.